So handing over to Aser, who's going to talk to us about wild Pacific oysters. Thank you, Aser.
Thanks a lot, Karen. So, hello, my name is Aser. I am an Earth observation scientist at Plymouth Lab, and I've been there for 10 years. My role is quite wide in the sense of mostly Earth observation applications, but part of my role is also to look after the drone capabilities at PML and also expand their use. And it was actually Karen who introduced me to the use of drones 8 years ago. So when I see you in a conference, it's like a very good sign already. So thanks. Today I'm going to talk about mapping invasive Pacific oysters with drone imagery and deep learning. And I think it's a really good example about how machine learning can be introduced into Earth observation for ecological management. So, Pacific oysters were introduced in England around the 1920s, mainly because they are huge and for commercialization. But outside those kind of farming, aquaculture, they are considered an invasive species in UK. The problem is that they grow very quickly and they form reefs kind of blocking the entire space. So they have the impact that they could displace the bilbao any other kind of community that lives there, but also attract specific predators. So on marine protected areas, it has the potential impact of displace the entire food chain. What they usually do is simply try to go out with a few volunteers, which they also do some kind of outreach events, and they teach them how to identify Pacific oyster, and they simply walk and count these oysters. Usually it's not just 5 people, usually it's like 100 people. It's a very laborious task. And obviously they cannot access some areas that pose a risk, like mudfloods. And honestly, in UK, the native oysters are subtidal, with the Pacific oysters are intertidal. So it would be strange, but exceptions can happen to find the native oysters on that region, but they have the Pacific oysters, they have a very distinctive shape and color that can be leveraged for their detection. So the problem was, this problem was raised to me, and they would say, can we tackle this issue? I say, oh yes, I think with machine learning and Earth observation we can provide an answer to that. This is a published paper, so you have the reference there in ecological informatics. So for this talk, I'm going to go very quickly over the slides. Feel free to go there later. So, Pacific oysters take around 20 months to develop adulthood and reach that kind of shape and color. It's slightly black on the edge. And usually, that adulthood are between 8 to 15 centimeters. Commonly, they live for years, are much larger, 20 or more. They're huge. So, on this case, for me, the key was what is the pixel size in order to cover this region and collect those images to be able to detect the Pacific oysters. So we were all stunned because I never seen an oyster on the field and picking up, having a look. And when I was looking at the problem, I said, okay, if you fly too close, you will not be able to cover a long region, and you will have a lot of detail, and sometimes it's not good enough. And then if you fly very high, you will not be able to resolve individual Pacific oysters. So after a bit of literature review, I selected okay, at the very least, we want to be on the medium side of the detection, and that translates to at least half centimeter per pixel. So when you are flying, if you are never heard about drones, it's fairly easy. You have your parameters of your drone and your camera in the flight mission plan, and you say, okay, if I fly at this altitude, which will be my pixel size. So would simply did a lot of planning with Natural England and South Devon area of outstanding natural beauty, Nigel Mortimer. And we selected 2 sites that were well known for having very high number of Pacific oysters. Along Kingsbury Estuary. One was a mudflat, very difficult to access, and the other a rocky shore along the coastline, which also poses a risk. Being intertidal, we started at low tide, but when we were going out, it was difficult to get into the ship. So this is the mudflat. is the orthomosaic along the coastline in the Rocky Shore. And simply we wanted to have our training and validation data set as most representative as possible of all the environments. So we selected on those orthomosaic I was showing you, manually some regions, trying to have all the different possibilities such as close to the water, far away from the water, obviously rock and mudflat, but also large congregation of oysters or spars close to algae, far away. And with those kind of regions selected, we used the individual photos with a bit of overlap to classify. And my colleague William J., he spent 10 working days simply drawing embossed around Pacific oysters. In 10 days, he was able to roughly tag 7,000 oysters, not doing anything, and he got those kind of mouse that you have like a ball. So he didn't develop any injury, thank God. And we simply split that into 70% training and 30% validation. We also run a bit of augmentation. So you have it here. So yes, a bit of a rotation, shift, and also color translation. And we tested 4 different models. So it was faster RCNN, YOLO 5M, YOLO 5S, which is the smaller one, and TPH YOLO, which was already pre-trained using drone imagery. And we simply wanted to see if it was a better model. What we found quickly is that faster RCNN was the best model in order to get the larger number of true positive. So it was able to recall more oysters that were on the field. But the problem is it was also raising the larger number of false negatives, which means, of false positives, which means, yes, it's very good at recalling what is there, but it's introducing a lot of oysters that in reality were rocks or something else. On the other hand, YOLO 5S, and to be honest, to some extent, 5M and 5S are scoring very similar, was much better of having a very good precision, around 88%, with a lower recall, but if you are planning an expensive action when you go with hundreds of volunteers in order to, what they do is count them but also kill them and remove them, so you want to know that what you are seeing is true rather than overestimate perhaps. So for our case study, YOLO 5S was the best. And simply to give you like an idea, so if the green boxes are the ground truth, in this case, what the operator William J. tagged, and the blue boxes are what it was raised, you can see if something is only blue, it's a false positive, and if it's only green, then it's a false negative. So yes, YOLO was increased, had more false negative, but faster RCNN had more false positives. This is simply to give you a visual idea of what we are looking for. So, and what of that? So the good thing about doing this kind of survey is now we can convert that data set into UM, and now we can compute how many oysters, Pacific oysters, there are per square meter. So you can give this to Netherlands, England, and say, well, your data now is geolocated. I can tell you where are the sinks, and rather than simply going there and measuring a few different square meters, you have a completely location of all the oysters, but also you can come back and compare. And there is a well-known fact that because of the warmer climates, Pacific oysters are going to expand into UK, and so therefore with this kind of data set you can come back, compare, and you have that kind of data needed to model, which I think is quite important so to the impact of why machine learning could be really good for specific samples on Earth observation, and to some extent very simple to use. So in this case, it's not here, but I think we have roughly 3,000 oysters detected on this site, around 1,000 oysters here, and it's very easy to see where the hotspots are. So I went very quickly because I thought it was 10 minutes. I am 10 right now. So I think the key for this is simply deep object detection is really good for ecological management, and it's very easy to apply for ecological management in this case. We report precision up to 88%, which is really good. To be honest, I had this conversation with the people that list those volunteers and say, well, we sweep through, and then when we come back, quite often, if they are on the rocks, they use hammers to kill them. When they are coming back, they realize that they lose so much and they still miscount them. So 88% for them, it was quite good. And I think it's really good output, especially for an old version of Solo. And with that kind of UTM, you have that time series needed for both management and also the model, creating new models. And it's a cost-effective solution, especially to those sites they cannot enter, like mudflats, but also vertical cliffs. So when it's intertidal and you have a vertical cliff, you can still point the camera facing forward and create the same. This is what I wanted to present. The paper is published. Thanks a lot to all the people that came to the field campaign, because we really stressed the amount of days that we had in order to get the most out of it. So we put a lot of hours, and thanks a lot to Dave as well, because I never had the chance to thank you as well. This was possible thanks to NeoDAS and 4Winds project, which I forgot to put it there. And 4Winds was a collaboration between Plymouth Marine Laboratory and University of Lisbon to foster collaboration and also train PhD students. So see, this is also a chapter on Silvia Almeida final thesis. So thanks.
Thank you, Aser. Any questions? Yep, Andy.
Really cool seeing it work so well from the monitoring perspective. Can you say anything more about the possible efficacy of the management interventions? So rather than just monitoring the problem, what's the likelihood that this could be put to effect?
So right now, the problem is the same everywhere. They are short of staff, so they don't have the time to actually go out and do the surveys as often as they would like. But especially now, Nigel Mortimer from South Devon Area Standard Natural Beauty, he really wanted to have that kind of knowledge. To some extent, at some point, they were actually using GPS in order to measure individual and logging that in a notebook. So the amount of effort that, just because they are volunteers, they really put into this, I think just using, they can use an RGB data, and the model is in Synodos. If somebody wants to use it, they can. So I think it will open that kind of possibility to assess quickly and then come back if needed. That otherwise, right now, is not possible to kind of cover that entire region just by one or two person working. So there is a lot of interest around marine protected areas, and I've been on a couple of calls with people looking at marine protected area in Cornwall. It has been a problem to find the proper funding for that, but yes, there is some interest. Does that answer your question? I hope.
Sidesteps it neatly.
I've got a couple of questions for you. So one of them is a data question. In terms of the sort of errors of the false positives and false negatives, I wondered, did you try feeding into the model a DSM or something from the drone photogrammetry, for example? Like, I mean, I don't know about the oysters, but I wonder if they stick out of the sediment and therefore you could use a topographic indicator of them being
Yes, we didn't do that, but it's a very good start. We didn't do that because it was a short project, but we could do it. Very interesting that you say it, because we just got a bathymetric LiDAR, and one of the benchmarking will be to kind of measure that roughness in the intertidal to see if we can detect even native oysters which are subtidal with that kind of roughness from.
Yeah. Okay, cool. The other question was a more, I'm not coming at this with much expertise about the different models that you use, but I thought it was interesting that you got really different outcomes from those different models, and I wondered why that is. Like, what are they doing differently to each other to give such vastly different answers?
That's a great question. I'm going to look at Dave because I think he will be much better if he wants to reply to that question. But how do you feel? Why is the difference between faster RCNN than YOLO?
I'll need to have a think about that one and come back to you if that's okay.
Yeah.
I can't come up with anything off the top of my head other than just making stuff up. So that's all.
We talked about this, and there was a reason. I
remember that as well, but I can't remember what
Yes.
that reason was.
Yeah, cool. Okay, well, we can talk about it.
Yeah, we can talk about coffee.
Any other questions? Yeah.
The data set that you created is quite impressive, obviously, that there's 10 days, you said, of someone labelling 10,000 oysters. And was that bounding boxes, did you label anything else, or was it just sort of a binary oyster, not oyster?
Just bounding voices, simply oysters.
So I wondered if adding additional classes could have helped with the false negative, not oyster, not possibly?
Very much. This was like a feasibility study to some extent, like a third project, and it would be great if we have the opportunity to expand on that. Yes.
And the human hours to be able to do that.
Yes. So we had 10 working days to tag oysters, and that's what he did.
Well, at least he'll be very good at doing it now.
Yes. It was amazing. I think he really took the effort. He led it.
Okay, maybe one very quick question, last one.
Just like the models, I don't know if you've mentioned the number of parameters in each or the number of layers, that sort of thing, because that might make a difference for why some of them did better than others.
Good question, because it was only the bounding box. I think it was related to how it identifies the color and shape, which is the important features. But yes, this is something we can talk about coffee break, especially I did design the project, collected the data, a bit of the split, quite a few things like overlap, how we filter the ingredients, but it was mostly Kate and they who did the machine learning part.
Okay, thanks, Aser.